when we were looking at gradient before, we could classify them as, we could classify a point on the curve in certain ways. Do you remember those things? What were the ways we can classify them?
Increasing, decreasing.
Right, so when we're looking at like a basic curve, over here, we were looking at its gradient, right? And we said something like this was increasing.
Stationary.
Something like, yeah, and then we said there was something could be stationary. What does it actually mean when a point is stationary?
So
Not
gradient.
moving.
Gradient zero.
It's gradient zero.
Gradient zero.
Gradient-
Hey! You stole that off me.
Oh, yeah, I did.
She's good.
And the gradient zero, or f dash of x. Right? Now, when we look at stationary points, we may take them at face value and say, okay, if we've got a stationary point, that's just when the gradient is zero. And that's right, it's right. But when we look at stationary points, there are actually different kinds of stationary points. Does anyone know where this guy is here?
The train station.
It is a train station. Does anyone know which one?
No.
Is that No, is that Epic?
I know it.
Epic.
Is it Thorn Lake?
It's
Is it Epping?
the one that you haven't said, which is very close by.
West Pennant Hills.
Cheltenham.
Pennant
It's
Hills.
Pennant Hills,
Yeah.
yes, it's Pennant Hills Station. So, this is one type of station. We've got other types. Does anyone know this one?
Harry Potter.
Platform 9 3/4.
Did you really go here and take photos? Or?
No, I've
Harry
been
Potter.
to the Harry Potter one in London. But, so when we look at these, right, we see these stations, and you know, they may seem boring, but there are different kinds of stations. In the same way, our stationary points, right, initially, we just got a gradient of zero, that's it. But we can actually have different kinds of stationary points. Let me give you an example. Okay, if I looked at this function here, or just off the top of my head, what is that going to look like?
Problem.
Yeah, so if I graph that,
A positive.
x squared plus 5x plus 6. This kind of stationary point is interesting because you can see the stationary point occurs here, right? If I drew it slightly differently, if I did minus x squared plus 5x plus 6,
Oh, what's going on there?
where's my stationary point now? What's
The
the difference
opposite?
between these two stationary points? So I've got one here
Oh, one's a lot bigger.
and one there. What's different about those two there?
Oh.
One's at the top, one's at the bottom.
Okay, one's at the top, one's at the bottom.
Different size.
Okay, so we actually classify these differently. Okay, so if I look at something that's a minimum, okay, one at the bottom, okay, then I need to think about it in a certain way. Now you use the word the bottom, right? The thing is though, we can't really use the height of the function to determine that, right? Because I could shift this parabola down, I could shift it up, so that's not really a good indication of whether something's at the bottom. If you look at them, look at the gradients of these curves, right? Try to use the gradient as an idea of determining whether something's a minimum or maximum. If I look at the gradient of them, what's the gradient leading up to this point on this curve? It's going down, right? So the gradient function, those values would be negative.
Leading to a minimum.
Yeah, but then this one, as I'm going up,
Positive.
yeah, I'm positive. So when I look at a local minimum, I'm decreasing from the left.
Pretty much it's opposite.
And then what's happening on the right? I'm
Increase.
increasing. Good. And then obviously, if I think about a local maximum, where I'm quote unquote at the top, what's happening with the gradient function?
Increasing on the left,
Good.
decreasing on the
It'd be the
right.
other way around, right? You can say this parabola has a positive gradient leading up to that point, and then as I go down, it's negative. Nice. So I'm increasing from the left, decreasing from the right. Okay. Now there's actually another type of stationary point, which I might introduce a bit later. So maybe leave a gap here. I don't want to overload you at the moment.